right. All right. Thank you, everyone. Thank you for joining this session. Okay. This is Top Media Technology, and we are information technology service provider. We are a full IT spectrum solution provider for Kingdom citizen, also for the world at large, uh, for a purposeful life. Okay, so we render service to the people in the world, both small scale startup business, large scale business, schools, wherever. Okay, we provide service and support for them. Okay, and especially the Kingdom citizen. All right, so this is just brief my agenda, but then again, let me quickly introduce myself. My name is Tim Fak, and that's just the short form of my name. And my full name is Timothy Fakayode, and I'm a Kingdom citizen teacher. I, I'm passionate about the Kingdom of God, and also I'm a technology enthusiast. Okay, I have passion for technology, and also I'm a co-founder of Top Media Technology and founder of the Purpose Ministry. Okay, so IT infrastructure engineer, also cloud engineer, helping the world, kingdom citizens, impacting lives, and see how we can use our skills, our talent to touch life out there, and also to put food on our table, to be able to, earn a living. Okay, so we have the test skills, and then we are passionate about the kingdom of God to live a purposeful life. All right, so um, briefly, at a glance, you can see at Top Media what we are all about. Like I explained before, we are full spectrum of IT solution service provider to the world and also to the kingdom citizen at large. And you can see the services that we render to the people out there who are our customer people that needs our services. It can be from school, it can be from non-government organization, it can be government partner, it can be schools, can be fintech, it can be individual, can be churches or mosque. We actually render service to everyone in the world. Okay, so if you watch my previous live, or probably you join or you watch it later on, I explain each of these services call solution that we provide from cloud down to the IT consultancies. Okay, so you can go back to my previous video or my video previous live, and then you can see a lot of things that I've explained regarding this. Okay, so for this today's live, we are starting from the second aspect of area of expertise, which is networking, and then we are picking the part of Cisco uh, uh, OEM, Cisco, which is the original manufacturer of these products, right? There are some other ones we have Juniper, we have other ones that we can use, but we want to concentrate for now on this. Okay, so why others we, but if you really want to go into IT, maybe you are coming from different background, or probably you just want to see where you are fit into, right? You can actually look at this and say, okay, go back to my previous video where I explain each of these area of expertise that you can, you know, put yourself into, and see the one that you are passionate about. You can see the one that actually suits or fits into your interest, and then go for it. Trust me, you are going to enjoy this today's live, and not only that, you are going to enjoy my YouTube channel. If you are going to venture into IT, you need clarity, you need direction, you want to get one or two things regarding some of these uh, area of expertise, just jump into my YouTube, and then go and enjoy yourself. So today, like I said, we are picking the second one here, which is the networking part, and we are going to start from the basic foundation, and also actually put this together in such a way that it will be easy for both professionals, expertise, or layman people, or anyone that is just like, let me go into IT and let me see how I can fit into this IT. So all my explanation, all my diagram and everything is very simple for anyone to grab. So the idea is that even though at the end of the day, after watching my video or joining this live, and then you decide not to go for this any of this what's it called, area of expertise, right? And then you said you want to go something else. But when you're in a circle of people that are talking about this solution, this terminology, this technology, you can easily relate with them, so that you will be like, what are they saying? Okay, so So sit back and enjoy the live session. Okay, so today we'll be talking about a very important topic, a very basic foundation when you're talking about IT and networking in IT, right? When we're talking about networking, you need to have understanding of IP addressing, right? And this is why I'm going to make this very brief and very short and very simple for anyone to grab. Okay, so today, like I said, we are looking at Internet Protocol IP version 4, IP version 6, and TCP IP, right? So, uh, talking about the foundation of networking, these are part of what you need to have at the back of your mind as you are going to the area of networking. So, like I said, it's a beginner's guide to how network works, right? Now, before I use this diagram to explain all about IP address, version 4, version C, or TCP, whatever protocol, right? Looking at this diagram here, it is just like a simple diagram. It might even look complex to you, depending on your level of expertise. But again, let me just use what I'm doing currently to explain to you in a layman understanding so that it will be very clear to you. So, for me to communicate with you, with the audience, for me to go live, what we are seeing here today in my screen actually, currently happening because for me to present myself or present this screen to you, there is a communication. There is a use of internet service, right? So and that is what you can see in this first diagram here. That is what you can see in this first diagram. Sorry, let me go back. That is what you can see here, right? So I have my computer, my laptop here with me to be able to go into YouTube, down to my YouTube channel, create a live, go live for you guys to be able to see me and to be able to communicate, right? So without my internet, without my laptop, I won't be able to have access to the YouTube channel. And without YouTube channel, I can't actually connect to the internet. Without internet, I can't even actually have my audience live. Okay, so um, let me check before I proceed. I want to make sure I'm carrying my people along, those that are live, and then to confirm if they're flowing along. Okay, so all right. Please let me know if you cannot hear me so that I can check. Okay, so let's go back. Okay, just give me a moment. Okay, I'm going to share back. Just give me a moment. All right, cool. Now, I'm going to share my screen back for everyone to see. Okay, let me know if you can see my screen. All right, so now for my computer to be able to have internet access, I need to have a subscription with internet service provider, which is what you can see here, ISP, right? Internet service provider can be Spectranet, can be MTN, can be other providers, right? Depending on your choice, right? Which you have to buy a certain uh, bandwidth, right? So you have to buy depending on your subscription or whatever you want to do, right? Okay, so once you buy that, you can buy that and have it on any devices, but the faster devices, like you can see my scripture, I mean, as you can see my screen here, is router. The router can be that big, can be that small, right? Your computer connected to it. The other one you can see is a server, right? Yes, it's a server, but is depending on your workspace or depending on your environment, depending on your task or depending on your scope or whatever you want to do. You can actually connect to internet without saver once you have your router, right? But again, like I said, depending on what you want to do, you can have that to it. So I just want to make this explanation very simple so that I can carry other people along. Because this video, this YouTube channel is not meant for just professionals. It's meant for both professionals. It's meant for professionals, for those that are just coming in from different background, want to go into IT and they are looking for where to get that source of information about IT. They want to see how they can. In fact, for professionals that actually want to brush up and all of that, or probably want to just go back and see how things work, they can always bounce back to this place and check things out. All right, so um, let me now explain briefly what you have here in the diagram. Here you have here we have the cloud. Like you said, you watched my previous video and you said you want to ask about what is cloud, okay? And like the word, and like as you can see on the screen here, cloud is just like a normal. There's a picture of cloud up there, right? So it might look like cloud up there, but again, we are talking about a specific location, a very secure location, right? In fact, it's a physical location. But again, like I said in my previous life, right, God Himself is actually the creator of cloud. God Himself happens to be the first and the only first that actually downloaded, information from the real cloud to human. That's happened in the book of Genesis when God was relating to Moses, as I explained earlier in my previous what's it called life. Okay, so Moses received downloaded raw commandment from God, from very, very secure place up there. So that is the method human being actually put together to ensure that okay, there's what we call cloud, to be honest with you. But again, cloud, whatever you might call it, is a very secure place that your information is actually secure, safe, without any breach. So you can see the second one here is internet service provider, yeah, ISP, right? This is like I explained before, it can be Spectranet, it can be Smart, it can be different one, right? They also tap their source from cloud. But then again, the router comes in, which can be what you have your subscription or bandwidth, you know, configured on, and that is where your computer, for example, here is server connected to, right? Sometimes in between the router and the server, you can have your computer here. But this diagram is not for just home use, it's not for personal use, it's more like for small scale or large scale enterprise or startup business. Okay. So the server is just it house different storage, it house different services, okay, depending on what you want. Down here, you see switch, right? This you can see different ports on this switch. You can actually plug as many computer that you want. This computer here on the internet over the network, the ISP or whatever sees all these computers as users, right? As users. So, and if you look down here, you can see uh, computer, electric computer, you can see printer, and you can see PDA. Okay, so all of this connected to this port. All of this connected to this port. This is like I said, it's not personal use, it's not home use, it's more like for a startup organization, right? I hope I've been able to explain briefly how this thing works. Like I said before, even myself communicating to you right now using my computer via the YouTube channel, connect to the internet, talks about IP version 6 or version 4 TCP protocol for devices, as you can see here, to be able to communicate over the internet or over the network, right? Each of these computer here, like I said, they are human over the network because it sees this computer as human, and human actually the one using this computer as you can see here. Sorry. Okay, so and each of these computer have what we call MAC address. Put that aside, all of them can be identified on this port on this switch. And aside from MAC address will just show that this is a device and this is the number of this device, right? But aside from that, there's what we call Internet Service Protocol, like an IP, Internet Protocol, right? So this IP is what this um, switch used to identify each of these computer. It assigned IPs for them. The IP allowed them to be able to communicate with each other. It allow it to communicate with each other. So when a user is using this computer, the user is using the computer, the over the internet, right, or over the network, is not seeing the user, is only seeing this computer as user. That's why I explained earlier that this computer over the internet is what the user uses to connect. So when you are connecting, it's not seeing you, but it's seeing the computer, it's seeing the MAC address of the computer, it's seeing the IP address of the computer. Okay, so let me quickly move on to the next one. The next one here is the postal system analogy, TCP IP. Yeah, so I explained in a previous slide about IP. Basically, I didn't go into TCP IP in fully, right? I just explained IP version 4. Like I'm going to see on this slide as we move on, I'm going to see talk more about IP. I didn't want to go into detail, but we have all the information on this slide. Let's just take it one after the other, okay? So that we don't just bundle everything together. Okay, so now we all know what we call postal system, right? For example, when you have a posting office, you have something to post to another location, and then there's a post office whereby you go and drop what you want to post to the other location, and then they get your information, the address, the person receiving it, all those direction, right? Give them you have to document those information to them in the post office so that your package can get to the right destination without any breach. That is what we are using as an example here. And as you can see from my picture here, right? Uh, this is a this is where the information have been packaged. You can see the house, you can see the envelope. The information has been sealed already, but then this information needs to go to the other area. Needs to go to the other house, as you can see here, right? For this information that have been packaged and sealed to get to this other, there must be a middleman. A middleman happens to be the post office or postman, let me put it that way. So let's assume this person actually needs to come to this post office, document this information package is coming from XYZ and it's going to ABC. Oh, it's coming from XYZ and it's going to ABC, right? It gathered the information here on the post office and then it takes it directly to the ABC and there it remove it, as you can see, it open the envelope and deliver. If you look down, the same thing applies to the way information work over the network. The way information is being passed over the network, computer here, the information is being packaged, it's being typed, the request is being sent over the internet as the post office now, then down to the destination. That is where it is being open and then it's being received. Okay, so now what is TCP IP? Let's use the example of the post service analogy that we have here. I'm using this as an example so that, of course, expertise, a professional will see this, they will understand. But again, also, I want the layman example. I want it for those that actually coming to IT or coming to this video for the first time and they want to use that opportunity to say, oh, this is how this thing work. Thank you. At least something is not making sense to them. Okay, so now layman explanation TCP IP is the rule book like an instruction, rule book like a directive, rule book like a blueprint, like a map for how data travel across the internet. Like you can see here, think of it. Okay, now, like I said before, a postal system, a postal system whereby you have a letter, a written letter that you have written, and then you put inside the envelope and you seal it up. Mind you, that letter had been sealed, and nothing should breach that letter. Integrity of that letter should be intact. Authenticity of that letter should be intact. Okay, so how can you make sure this letter, as it is here, get to the right destination? Here, the letter at this point is a data, it's an information, and you want to send it to another location from location A to location B, right? For example, in a normal envelope that you have written your letter that you have sealed together, for that letter to get to a destination, you need to have an address. Where are you taking it to? The letter is coming and is being sealed from ABC and is going to XYZ. What is the address of the destination of XYZ? Right? Physical address, for example, for the postal system that we are using, for example. But for IT related process or IT related system, it is the IP address that stand as a physical address or like a physical address on the postal address case that we are talking about here. Okay, so the postal address uses home address, physical address of that house, of that street. For example, the destination is XYZ at number 2, the town, the city, the number, the street. Okay. Then the information will be passing each of those instructions, right? The city is XYZ, the street is straight, the number is this. Till you get to the doorstep of the house, you drop the post letter, right? The same way for data over the internet, it must have an IP address. An IP address here, like I explained before, is the internet protocol. It is the address of the destination where the data is going. Then the next one we have here is register mail. It's like a tracking. In the case of physical postal address, you want to post information to another location physically, you want to post a letter to another place, you need to track uh, that letter. You want to know at what point this letter has gotten into. Is it still on the streets? Is it still at the number to number so so so, or is it still in the city, in the town, right? So here in the case of IT related in terms of data, transmitting of data, moving of data from one location to the other, this is where TCP comes in. TCP, what I'm talking about here is related to uh, how this actually transmitted, right? It's reliable. It checks everything on arrival. For example, you are taking this letter that has been sealed from house A, city XYZ, number 2 avenue. You are taking the letter to city Washington or city whatever, right? Number 8B, you know, street. So as letter get to city Texas or Washington, whatever, right? And then landed to the street, is checking the arrival, is checking each point the letter has gotten to until it gets to the right and the last destination. Okay, that's where the TCP comes in. Then moving on to the regular stamp, when you receive letter, when you receive the letter, you stamp it and all of that. That is where UDP, and UDP is more of unsecure or I mean unreliable channel compared to TCP. These are protocols, right? These are protocol. Then if we go down here, we have, sorry, excuse me, post office, you know. You have to take the letter to the post office, and that is where they will now get your information. Oh, I've received this letter from you. Okay, this letter I've received from you. Where is it going to? Who is going to receive it? Which city? Which street? What is the number of the street? Right? What's the name of the person receiving it? The post office receive all this information and send it to that same the destination as you have, supply. And that's the work of router. Router actually routes data to the right destination. That is what we call traffic, right? So now the key takeaway here is TCP IP is a stack of protocol. It's a stack. When I say stack, something that is arranged. It's not something that can be jumped. It's not something that can be, you bypass. You have to follow those steps. So the stack of protocols working together to move data from one point to another point. So that is so for the sake of newbies or for the sake of people that are joining IT or networking afresh, IP, like I said, is used to identify devices over the network. Now, a device that has been identified over the network, its primary purpose is to send data. IP 1234 has been identified over the network, and you want to send uh, that IP 1234 want to send data to IP 8910. 8910 is another device that has been identified over the network. So that is the IP part of it. For two of them to communicate now, they either communicate via TCP or UDP, right? They either communicate via the TCP or UDP, and I've explained here, right, their functionality. TCP and UDP actually, are meant for the communication, but one is reliable, the other is not reliable. Do you get it now? So once they have been identified by the network, for them to communicate, they need to use a particular protocol. All right, thanks so much. So moving on, like I said before, that this is like a stack, and that is where these 7 layers, I call this magic map, comes in. The OSI layers, right? In a layman example, I want to use a building as an example, right? Of course, like I said, professionals and expertise, we understand this, but so that everybody will flow along, we say a building, right? Let's make it a story building to make it more. You have the ground floor, you have the first floor, second floor, depending. Let's say till seventh floor, right? Just give me a moment. Let's see if I have anyone here ask 1 2 questions. Okay. All right. Thank you, Joy. I can see that. Beautiful. Yeah, thank you for joining. The audio is fine now. Thank you. All right. So moving on. Let me take a quick look at. All right. I'm sharing back. So now you can see the layer from up down. Layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, layer 1. Okay. And each of these layer work together to achieve a purpose. Right? They work together to achieve a purpose. Now, we have the application layer, we have the presentation layer, we have the session, excuse me, we have the transport layer, we have the network layer, we have the data link layer, we have the physical layer. Okay, and each of them have explained a simple term in a layman example, right? Number 7 layer, right, is application layer. Of course, we'll be hearing the word application, 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 right? YouTube is an application. Your browser, Google Chrome, Microsoft Edge is an application. Any application that you're using for particular is an application. It work over the web. It work on a app, right? Now, I've used an example, a building, story building. Now, the application layer, for example, in a story building, is like the living in a house, living in the house, right? The app you see is an example of living in the house. For example, let me give an example of let me use Facebook as an example. Facebook actually there's a mobile app. You can actually access it on the browser as well, right? There's a browser way of accessing Facebook. There's a normal app that you install. It can be a mobile app. It can be the one you can install on your Windows computer or Mac computer. Okay, so now you have to know the one you are using. Let's take, for example, like I said, living in a house, the app that you see. Let's, for example, here we are using the case study of web browser. Okay, the web browser you can use your Google Chrome, you can use your Mozilla, you can use your Edge, Microsoft Edge. Here is web browser. Now, just go online and enter facebook.com on the browser Edge and it display your login page, login username and password. Okay, that does not just happen by magic. This layer 7 that you are seeing here actually has already worked within a twinkle of an eye. For that application that you type on the browser to be able to show you the landing page or to show you the login page shows that it has passed through the 7 layers. Shows that yes, it has passed through this layer 7, layer 6, 4, I mean 5, 4, 3, 2, 1. I mean, even physically from 1, 2, 3, 4, 5, 7, it has passed through everything successfully till you get to that layer 7. And that is why you're able to see the login page. That is why you're able to see the landing page. Okay. So if layer 1, the very root, the very basic, the very root, right, is failing or is not working, whatever is going to happen by the time you type in that uh, facebook.com on the browser, you're going to get an error display. Something went wrong. Site not reachable. Why? Because it has failed from one of these layers. Are you following along? So now, for that facebook.com on the browser to display, like I said, each of these layers must be passed and checked successfully. If anyone fail or break, it will not get to layer 7 where you have to see the landing page, the password for you to log into the browser or Facebook. Moving on to the one of layer 6, presentation. Yeah, in a layman example, I said architect blueprints or architect whatever. Uh, yeah, part. What this is doing, or the network device using is encryption forwarding. Encryption forwarding. Like the word says, presentation. It presents to you, okay, this is what is coming, take it. Right? It doesn't just take it or present to you, it presents to you based on the format that has been set. Okay. Now moving on to number 5, session. For a layman understanding, here it is called keeping the door open, maintaining conversation. If you have been in a space, you have been with people that talks about developers, right? This session is something that make uh, it's like an active uh, process or active action, active connection. Let me put that way. Connection has to happen between two people, and for that connection to be active, that is where session comes in. So as you can see here, you have APIs, net bios. That is where it happens. Then moving on to number four, transport. If you call it transportation, fine. In a layman understanding, moving truck is what we use here. Of course, moving truck is reliable, far and fast delivery. So you want to transport what you have gotten from the source to destination. And that is why I explained to you TCP IP. Again, you have to have this at the back of your mind. TCP IP. It's not a magic. It's more like a data is moving from a source to a destination. The source must have an IP over the network. The destination must have an IP over the network, and there must be a means or a protocol for them to communicate or for them to move. That is where TCP comes in. Okay. All right. Moving on to layer three, networking, which is the area that we are currently, and then we are delighted to be here. Right. Here, in a lame understanding, I use GPS roadmap. So, where is this happening? It's happening router on a router device. It's happening on switch. There are three switch. So you have a data that want to communicate, and that is where we also bring in the idea of office, post office, where you go and put your envelope and say, "Oh, this thing is coming from me, and I'm sending it to social destination, and this is the address." So the router actually route, move, or send your data to another location, which happens to be the destination. Okay. Data link. Data link, as the word implies, is like a linking data. It's like a path, right? Like a street here in a layman understanding. So you said have a data over the network that want to send from one IP to another IP. So the next question should be which part or which route are we taking, right? And what you can use for that is router device. And inside the router device, you need to be able to know which part we have there. Do you get that now? Okay, you go to post office and say, okay, please let me deliver this letter to Canada. And I'm here from Africa, right? Okay, how can I do this? You need to give them the address, and your letter is going beyond Africa to another continent, right? You know, so it's not like it's not within Africa, right? It's not within the states. So we are going beyond of another location. Of course, within the state, you want to say, okay, I still want to send one or two things within my location. You might not really need router, you might need probably switch. That is why if you go physically to a post office, they will ask you, you see a local delivery or international delivery. Of course, local delivery is always cheaper compared to international delivery. Why? Because it's within the system, and in case of data, local delivery is like you are within the switch from one port to another. If you remember, I showed you the switch that has a lot of ports, and each computer were connected. For this computer to communicate, they need to have an IP assigned to them for them to be identified by the network, and then for communication to even take place within themselves, there's need of protocol. Protocol might be quite different from the one that we use for the one outside the switch, right? For example, we have switch A with about five computer, we have switch B with about five computer. This is switch one, switch B, switch A, switch B, five computer, right? And this five computer here in switch B can communicate locally. This is what they call local delivery, right? This is switch, other switch with five computer located. They can communicate to each other too, which is local. But when it comes to each of these five here and the five here to communicate together, or each of them to communicate with another outside their switch, router comes in. Routers comes in. That is where in a normal layman form of poster that we call that as international posting or delivery. All right. So now the physical one, which is number one, said the physical road. The physical road. If you look at data link and that is number two and then number one, they have something in common, similar in common. Right? Data link talks about switch. Number two, which is networking, talk about router, right? Then number one, physical, talks about physical road, the cable. So for them to talk, for the switch to talk with the computer, you need to have a cable. There is what we call LAN cable, whatever category of such, you need to connect to computer or to the server or whatever for them to be able to communicate. Okay, so now if you have a cable that is bad or not functioning or not even plug, you can't expect whatever data the computer is sending, computer from here, one of the computer from switch A to communicate to computer of switch B, right? It will not work because the cable, the physical road is damaged or it's not working fine. There should be a communication between them, right? So moving on to the next one is uh, the bottom layers, which is physical. The explanation I gave earlier is just for you to have understanding, but now let me go deeply. Layer one, layer two, the cable and the switch using an idea of receptionist. Like I said before, I'm using this video for both newbies you want to go into networking, you want to have basic understanding, you want to see if it's suitable for you, you want to know if you can fit into this area, come to my YouTube channel, subscribe, share with your students, share with your colleague, and ensure that you enjoy it. Okay, so talking about layer one, layer two, talking about data link, talking about physical. How do they relate? You can just see it here in a glance, right? This is the physical cable we're talking about. If this physical cable is damaged or it's not fine, it's not working fine, it will be very difficult for devices to communicate to the switch. Or the switch communicate with the device. At the end of the day, sorry, permit me. On this computer, you want to enter facebook.com. And for facebook.com to open on your browser, which is your layer 7, on this computer for facebook.com to open on this computer which is layer 7, this layer 1 which happens to be your cable and layer 2 which happens to be a data link, if they are bad and they are not functioning on your layer 7 on your computer, as you can see here, you get on the browser, you will get unable to reach the site or something went wrong or other errors, right? So layer 1, let me explain physical. The common problem here, my computer will not connect. And why? The plug, like I showed you on this diagram, maybe it's not firm, it's not well plugged, or the cable is old, it's bad. So therefore, it can't actually communicate to each other. Then layer 2 comes in data link or the switch. I'm using an example of receptionist as a switch that knows exactly which desk that happens to be port as which person MAC address. As you look at this diagram here on the right hand side, you see that each of these computer here have their own cable, right? and the ports they are connecting to. Here, this one is port, PC4 is connected to this or USB 4, and then PC3 connected to USB 3, PC2 connected to USB 2, PC1 connected to USB 1. Okay, now as they connect, right, each of them have all these computers, each of them have MAC address unique to them. The MAC address of PC4 is different from MAC address of PC3, different from MAC address of PC2, different from MAC address of PC1. Okay, so each of them have their own MAC addresses on this switch once they are connected. So the switch actually is so intelligent that it knows that on me, I have PC1 connected with me because I can see the MAC address. I have PC2 connected with me. Sorry, permit me. Let me quickly check my audience. Okay. Okay, moving on. If you're enjoying the session, thank you. I can see you, Mr. Anthony. Okay, if you're enjoying the session, you can drop a thumbs up. All right. Now, briefly, I'm going to explain how this works. How it works. It reads the MAC address, just like security, social security number for your device. Yes, and this is unique to everyone. Right. So there's no point of view the switch to say, oh, I don't know this person is connected to me. I don't know if this is plugged to me. I don't know if this one is there. It actually knows every device is connected to it. And it can actually, when you receive, for example, PC4 want to send a data to PC1, right? The switch is so intelligent that it knows that, oh, I'm getting something from PC4 and I'm seeing that I want to send it to PC1, he just send it straight to PC1 without disturbing PC3 or PC2. Asking PC2, do you know PC1? PC4 wants to send something to PC1. No, he won't do that. What does that is up. I mean, yeah. So as you can see here, no yielding, unlike up. A switch send data only to the right port, which is the correct port. And I give an instance, PC3 get PC3 data. So key take home here is that MAC table frames VLANs are actually working actively here, and they are the one that doing the magic. All right, they are the one doing the magic. All right, so moving on, we have layer 3 and layer 4. Here we talk about the router and we talk about the ports. Like I said in the other slide, the GPS and the truck driver. Layer 3 is part of network and router. Network and what? And router. So the GPS find the building. I use this as an example, which is network. A building is assigned its own network, right? And another building has been assigned with its own network. I told you, and I give an example that, let me give another example again with my hands, right? This is building A. This is building B. In building A, let me say we have a switch and five computers, one, two, three, four, five, are connected to the switch in building A. On building B, we have a switch as well, and five computer, one, two, three, four, five, are connected to the switch B in building B. Okay. Now, I told you before about the network. For computer to communicate, for each of these five computer in building A and each five computer in building B to communicate, they need to have IP. So computer one in building A, two, three, four, five have five different IPs on this building A. Same thing here on the building B. So the IP here, there's what we call IP range. And I said I'm going to explain to you. And if you look at my screen here, we are using IP address 192.168.1.1, right? Now, depending on the subnet mask, let's just assume here that this is uh, slide 24 network, right? What that means is that we have 192.168.1.0 network, right? And let's say we assign that to this building A. So what that means is that every computer here, each of these five computer have IP address of network 192.168.1 dot whatever, right? Let's say for example, this computer have IP address of 192.168.1.3.3. This one have 192.168.1 dot let me see 6 or 4. This one to have his own, this one to have his own, don't have his own. Remember the network all of these five computer in building A are having is network 192.168.1.0 network. In this other building, it's going to have different network entirely. It's going to be different from 1.0 that we have here, 192.168.1.0. Let's assume here in building B, they are using 192.168.2.0 network. So their IP address here too can be 192.168.1 and .2.3, .2.4, .2.6 and all of that. You can see they are quite different and they are in different what that has done is actually differentiate them that they are in different building. So for these guys to communicate together now, right? You know, before I go further, the communication between each of these five in building A is going to be a little bit seamless because they are the same network. Mhm. Communication between these guys two within themselves is going to be a little bit seamless because they are together in the same building. But for I mean for this computer one, PC one to communicate with PC computer one in A, building A, that is where router comes. All right, so now I've explained network and I explained router in just simple way. Router connect different networks. I've explained to you. Building A, this network is 192.168.1.0, and that is where all the I5 IP I'm picking their IP address from. And here, building B is 192.168.2.0, and that is where all the five computers are picking their network from. Okay, so now they actually come together to communicate using the router. Therefore, talks about the transport. Like I said, transportation, moving stuff slash port. And I said the truck driver. The truck driver deliver the package to specific loading dock port. That port, let me give you an example for a layman understanding, is like a doorstep. until whatever you are sending gets to the doorstep of the destination. That is when you know that it has been delivered. All this pay on arrival, right, is when you receive the package. You open the door, they knock at your door, you open, are you the one that ordered this? Yes. You confirm it and you receive it, you take picture. Let me give you an example of buying food from uh, online order, right? So you get so now this is done in layer 4. This is done in layer 4, whereby you order food online, they drive down and they deliver it to you, collect it, and they confirm that. Now, number B, I mean, letter B, TCP reliable, dependable. Now, an example is this for a layman to understand. Did you get it? Let me check. That can be done in web browsing or email. I told you before, TCP is like the protocol for that movement, right? UDP is faster but not reliable. You can easily deliver it. Oh, this is your food. Good luck. An example of that is live video game Zoom. But for TCP, which is reliable, it's asking you question. Did you get it? There is a message. Have you received it? Then you need to check and confirm, right? So the engineer note here is this: network engineer lives between layer 3 and layer 4, and that is where we are in this live session that we have, this our stream, okay? So network engineers live between. So when you talk about network engineer, they are in this layer 3 and layer 4. That is where they navigate. So moving on to the next one. Okay, I have diagram here. Then explain what I've been saying since. Okay, so now I think this will make it more clearer for some of us that actually likes diagram for more explanation. Layer 3 and layer 4, the GPS example and the truck I mentioned. Now, building A, like I said, let me make it building, let me make it, sorry, let me make it building 1. This is building 1 based on our diagram. This is building 3. Let me say 3. In the middle, we have building 2. And that one can be anything that you can put there. You can put anything there. But based on our diagram here, we have switch. Okay. Give me a moment. All right, thank you. I still have my audience joining. Let me go back sharing my screen. Just let me know you can see my screen. All right. Thank you for joining. So let me go back. All right. So now in this building 1, we have ISP, and I've explained ISP to you. For example, in this building 1, they are subscribing to 1 gig, right? For them to have access to internet. For this guy you have here, for them to have access to internet, we have computer here, we have 2 computer, we have 2 cameras, where they are tapping IP from this switch and accessing the internet, right? So each of these uh, computer and this camera have their own IP and MAC address found in this switch. Okay. Now On building trees, we have high speed, they are using data of 1 gig, and you can see the computer as well. Right. Like I explained before, let me give an example. Maybe each of these 6 devices connected to this switch are just like what you have in my hand. Like I have 5 fingers, right? So this guy can communicate to each other because they are in the same network. That is the explanation about network. And I've explained to you based on the IP. This building one can have 192.168.1.0 network where each of them will work and assign the IP address to them. Each of them can communicate, because the communication process will not be that difficult compared to this computer here to communicate to this computer in the building 3. And for them to communicate, computer in building 1 to communicate to computer in building 2, there are process in place, and that is what you can see here in this diagram. And this switch is doing that major work to communicate, right? To do the communication. Let me move this to do the communication. All right, I think in a glance you can see, understand what the flow is all about. So moving on, IP addresses and subnet mask. Okay, so I'm using this word, the neighborhood, as an example, so that we all grab it easily. This particular aspect of network I'm about to tell you is one of the difficult parts that if you don't have fundamental knowledge, idea, or trick about it, you get frustrated when it comes to IT network. You'll be frustrated because a bit calculation is there, a bit mathematics is there, which you have to be very, very careful. Right. So now this aspect is very, when I'm coming out with this slide, I'm looking at how, because I don't want people to go through the tedious part that I went through for me to grab this role. So I want it to be a very simple way that at a glance they can actually understand, oh, so this is the idea behind this. So now I use, as I was explaining network aspects and I was explaining um, the IP aspect of it, this is just a breakdown. This IP address had been separated with full stop, right? A dot. And then we have numbers in between, as you can see here, right? So I said 192.168.1. I say it's a city. And when you say it's a city, city of London, different city that you want, right? In that city, we have streets, we have buildings, right? We have different flats, but they are in that same city. Let's say city A. Inside city A, we have streets, street numbers, we have flats, we have buildings all together that people, go here and there, move here and there within that city, in the building or within the streets or within the complex or the flat. Okay, but they are not outside the city, within that same city. Now, that city is just for layman understanding, but then in the IT network terminology, we call it network ID. Okay, like I said, the full stop or the dot actually separated 4 different numbers together, and then the network aspect happens to be the three part of it, while the last one, have to have its own number for different purpose or reason. So the first three is network, is the city, while the last one is apartment. Now, that apartment is called host ID or computer ID or laptop ID. Let me just put it that way for people to understand, right? Now, The complete IP address of what you are seeing on the screen is 192.168.1.12. But we have to break it down so that you can know the one that belongs to the network and know the one that belongs to the computer. So IP version 6, I mean version 4 is 32 bits and it's grouped in 4. As you can see here, you see we have 192.168.1.12, making it 4 group. So IP version 4, ideally, we have about the total of 4.3 billion addresses because it's 32 bits in 32 bits in number. It's about 4.3 billion addresses. What that means is that 4.3 computer can have IP address. 4.3 user can make use of computer on the network to access the internet. So hypervisor which is the latest one, it has about 128 bits hexadecimal compared to 32 bits, right? And this is the height of it all. The total of 340 unicillion, enough for every grain sand on the earth. Like you want to have everyone on the earth to be having internet assigned to them. Yes. Few people or not much or not at all are currently not using this, but then people are still using and so familiar with 32-bit IP-4. Okay, people are not yet consuming or implementing IP version 6 because number one, you can see its capacity. And there's no point you spending money on something that you're not going to use, or it's going to just be there fallow, or just be there Jordan, just be there idle, just be there consuming money on resources. So subscribe, implement, deploy, or use what you know you can maximize. Okay, so now moving on to the subnet mask. We use an example of this IP address and said slide 24. What that means is that you have picked from 192.168.1. That is where slide 24 stop. I'm going to still explain to you how do we come about 24, but let's leave it that way from distance. This tech computer, everyone at 192.168.1. Hmm? The X is just the 12, is for host. And say everyone that means in this building here that is using this network of slash 24, which is 192.168.1, hmm, they are in the same building. So if any device is seeing another IP from here that is not in this building, then there's problem. There's problem. Okay, so assign, just give me a moment. Okay, so we will not be able to finish this session on this live. We continue. Okay, because I don't want this live to expand more than 1 hour. And from what I can see here, we have about an hour 30 minutes and so. Um, so I'm going to continue this live. We are diving into real deeper what's it called training. It's going to be very interesting, and also I'm going to upload part of this uh, session or part of this training video on my YouTube channel. Just keep your eyes on it. Be ready, prepared, and ensure that yes, you are getting something. Share it to other people for them to benefit. Those that want to go into IT and all of that. So I really appreciate your time, and let's keep on learning and relearn. Okay, Thank you so much. See you soon. Bye.